Good morning to everyone. That was Simon and Garfunkel, the boxer. And I'm on page 131 of the simple closed curve unit, and we're going to go to that in the document cam here. And what we have is a grid. You were supposed to draw a curve for that grid. So take out your work with your curve, and I'm just looking at what I see from where I'm sitting, and I can see some rather interesting shapes. They appear to be, for the most part, nice, smooth-looking curves. And you need to know where the inside and outside is. So as you look at your grid and the shape you have on it, you're going to see something like what I have on the board. So the possibilities, of course, are endless, the shapes that you can draw. So as I just look at the title page of this unit on page 127, as we go to the document cam, those are the possibilities of things you can do. Now, with camera 1, I'd like to just do what we had earlier. So I'll just be working from the board here and the document cam, and then we'll leave 2 freed up for a moment. I want camera 1 here. So camera 1 on the grid because I like to keep the parallax problem down. So for camera 1, when you can, bring in what we have here with me at the board. This is the shape I drew. Won't look like the one you did.
Mine does almost.
Okay, some of them may be fairly similar. But what we're going to do is, and I want to show what happened here, I'm going to use the grid that I have here. You're going to use the one in your book. And so the question is, first we're going to do what I looked at here. Then I'm going to ask you to do the same thing on yours. We're just going to plot a few points. Now, I ask you to do 50. But we're just going to look at a few of those points for the moment. And where is that table of random digits in your book? 136. And here is that table. Table of random digits. Now, I'm going to start at 9-3. And what I'm going to do is slide this over just so that we're looking at that first column. So as I come down, I'm looking at this column I'm in. And so what I did is plot some points, and we're going to see as we go down what we have. So I guess what I'll use is this portion of the ruler contributed by Adrian to the cause. Here are the first 3 pairs. I have a 9-3, a 4-0, and a 4-3. So let's see what we have on the board. I went over 9 and up 3. So again, the 9-3 says start at 0, go over the 9 and up 3. Now my grid happened to go past 9 a little bit, so it's not quite like yours, but at 9-3 I find myself right on my curve. So I consider that a point in. Let's go back to the document cam. My next point was 4-0. So as I come to the board, I went from 0 over to 4, and it's 4, 0. That 0 means I don't go up. I just stay. That's out. So 1 in, 1 out. So what I've done over here, and just tweak that just gently, a little bit more, just a smidge. I have kept track of in and outs. I'd like to keep track of that throughout, okay? So I'm at 1-1 right now. Well, I call these hash marks. Call them chicken. You can write however you want.
Okay.
I'm just keeping track like I'd be playing cribbage or something like that. So as I come back to the document cam, my next one is 4-3. Now we can tighten up a little bit more on this as we come back now because I'm not worried about the in and outs on this, Marcella.
You only want that?
Yeah, just what I have here now. So on the 4-3, as we come back to it, I go over 4 units, and then I went up 3. Now, if you have a grid, it's a little bit easier to keep track. I had to make lines coming across. But 4-3 is what? Clearly out in mine. Back to the grid, or I should say the table of random digits. My next 3, 2-7. So I come from 0, go over 2, and up 7, and that was just barely outside. Back to the document cam, I had a 5, 7. So over 5, let's come back to the board. So I started at 0 and over 5, up 7, and it's out. You get the idea. Now, I did that for 20 points. We went down through that entire first 2 columns, so back to the document cam. I just followed this all the way down to the end, and I had 20 points. Now, when I did that, as we come over to this part a little bit more, Marcel, so we go back to the board, you'll find, and I need to come down here, I kept track, and I had 8 in, 12 were out. Now, what about the area of my grid? I measured this grid, and when I measured it with a ruler, I found it was 2 feet by 2 feet. So there was 2 feet this way, 2 feet this way, so the square feet for my whole grid, 4 square feet. So I have to find the area of the grid. Agreed? Then I have to find the number of points in out of the total. So as I come over here now, I want total percent of points in of the total. So I had 8 out of 20. That can be changed to 40 over 100. And that is what when you do that? 40%. So the argument is that the area inside, and we can just slide a little bit more now, panning just a little bit more. The AI, area inside, that's not artificial intelligence again. The area inside is the percent, which was 40. The total area, we said that was 4 square feet. So I simply multiply 0.40 times 4 square feet and get what? 1.6 square feet. Okay? Now that's the idea. Okay? Now we're going to do this in a problem that's not been done for you. I'm going to ask you to go to problem 5 in the review test. Okay, so what I'll do is come back to the document cam for a moment, and then I'm going to center again at this point with camera 1, and you can use camera 2 for whatever we'll do on the front board. I'm going to go to, let's come off there for a moment whenever you're free. I'm going to go to the 5th question, and here is the diagram you see on the 5th question as we go back to the document cam. So this is in the text, and again it's a grid from 0 to 9. Now, if you have a straight edge with you as a ruler, you could measure the area of this grid. Okay, so that's, I want you on page 146 at the moment. And we want to measure the area of this grid. Now, my broken ruler, courtesy of Adrian. Okay, let's keep that there. There's my broken ruler. It starts at 9 and it goes to 11 1/4, so I'm getting 2 1/4 inches coming across this way. If you had a straight edge, you could measure it the same way. Then coming off that for just a moment, over on this side, again it starts at the 9 up here and it goes down to 11 1/4, so that would be 2 1/4 on that side. So your area should be 2 1/4 times 2 1/4. How are you going to do that? If you take 2 1/4 times 2 1/4. Okay, Marcella, over on the sideboard at the far right, you see where it says page 146? It has total area. Could you bring that in for me? And we'll look at the process here. So you're going to find the area of your grid. That's always your first step. There's a 3-step process, so we're going to go to that now. And there's your total area. And I did this in a couple ways, just to remind you of what can be done. 2 1/4 as a decimal is 2.25 times 2.25. You could do that on a calculator, and you might check that to see if you agree it's 5.0625. But 2 1/4 can be written as what? An improper fraction. 9/4 times 9/4 is 81/16. That's 5 1/16. And then what I did is a little game we played earlier. 1/4 is 0.2500. 1/8 is half that at 1250. And 1/16 is half of that at 0.0625. So I knew my answer was 5.0625, which is precisely what I have here for the area of the grid. Okay? And that is, of course, in square inches. Now this equal sign has to do with something else for a moment. So we're okay there? That's the area of our grid. That's step 1. So the question, what is step 2 as we go back to the document camp? In step 2, I have to find the number of points inside this simple closed curve. So I'm going to select some random points here, and I'm going to select those from a stat book. So this is our book we use in statistics, and this is going to be now a table of random digits. And here is my first, let's see if I can get this settled a little bit. Okay, here is my first, let's see, I'm going to bring that down just a little bit and focus a little clearer. Okay, well, you write these ordered pairs down. What we're going to do as we look at this page, I'm going to take the first 2 digits in each row. So the first 2 digits in row 101 are 1, 9. Write that down on a piece of paper. 1, 9. Your next pair, 7, 3. So that's where I got the 7, 3. Next pair, 4, 5. Next pair, 5, 2. Next pair, 9, 5. Next pair, 6, 8. Next pair, 8, 2. Next pair, 6, 0. 6, 0. Next pair, 3, 6. Next pair, 3, 8. We got them? So 1, 9, 7, 3, 4, 5, 5, 2, 9, 5, 6, 8, 8, 2, 6, 0, 3, 6, 3, 8. Okay, we've got them. Now we're going to plot those points on this grid. Let me get that a little bit centered better. There we go. There's my grid. And I want to plot the points on that. Now let's see if I can get that just a little bit so it's less skewing. So our first one was 1, 9. So what that tells me is I go over 1. So I go over take this at 1. And then I come up to what? To 9, and that's on the edge of the grid, correct? So that point is out. Agreed? So what you're going to do now, I want you to go ahead and plot these points. The first one was 1, 9, and it was out. I want you to plot the other points, tell me ins and outs. So again, I'll put the grid up on the screen. So if you're watching from home, as we go back to the document cam, keep in mind your points, and I'll give them to you verbally while you're looking at that. 1, 9, then we had a 7, 3, a 4, 5, a 5, 2, a 9, 5, a 6, 8, an 8, 2, 6, 0, 3, 6, and 3, 8. Now, if you're watching this at home on a television monitor, you might want to try getting a straight edge or something and just go up to the screen and see if you can decide if a point's in or out, much as I'm doing. So, for example, when I had 7, 3, you would just try to run some kind of straight edge up in the screen, much as I'm doing here. You're at 7. And then you come across at 3, and what I'll do, just with a piece of paper, is come up to where we're at 3, and you can see those meeting, and it looks like where the blue of the ruler and the white of the paper, it's a point that's outside. And then I can take that off and do another one. So that's the idea. Let me get that off. So if you're doing this at home, back to the document cam. So you can sit there and find these points. So we did 1, 9, and 7, 3. So it takes a little bit of time for that to happen, so I'll leave that on the screen. We need to plot. This is called plotting points or ordered pairs. If it touches the line, we'll call it in. Technically, we should flip a coin, but we'll just call it in. Now, this is going to give you a total of 10 points, and some will be in, some will be out. So we'll give you time to get that. And there are a couple points that are a little bit dicey. Okay, the 3, 8. Let's see what a 3, 8 looks like. Okay, if I do this, coming across, up, I should say, and then I want to go up to what? To 8. Let's see where it meets. 8 comes across, and at 8, if I have that balanced, boy, that looks to me like it's right on the line. So if it's on the line, we're going to say yes. Okay, so again, let me move that.
And when we measure,
Okay.
from 1 or 0?
You always start at 0. So if it's like 4 something, like it was 4, 5, you would start at 0, go over 4. So you'd start at your 0, go over to 4, and then up 5. On the one on the board, it was 2 feet by 2 feet. On the one here, it was 2 1/4 inches by 2 1/4 inches. You're going to have to measure it each time.
Yeah, but that's not even start with 0. You measure with a ruler?
You can, or you can start at any other point. I had a broken ruler, so I started at 9 and went to 11 1/4, so it's still 2 1/4 inches. Okay, coming off there, do we have them all plotted? Do we have some answers? How many did you have in?
3, 4.
I've heard a 3 and a 4.
I got 4.
How many of you have 4? Let's see your hands. How many have 4? Only 2 of you. 3 of you. How many have 3? 1 of you. How many others? There are 5? You have 5. Okay, now it depends how carefully you run the vertical and horizontal lines. I went through and checked each point of that list doing what I just did on the screen for you, and I found 4 out of 10. Now, if you found 3, then you made a different choice on one of the points. That is very difficult if your curve is such that the point is really close to the curve. So you may have 3, it may be just as valid as my 4. You may have 5, maybe just as valid. But you do have to have a number of lines for a grid that we didn't draw here. That made this problem hard. So what we're going to do, Marcella, is where I was before with the total area, I want to pick up the AI at the top there. So I'll walk over there once you get that in camera. Okay, so you have that there. Let's cut to that shot. Let's bring that in. And let's see what we do. Now remember, the argument here is that the AI, the area inside, is going to be your percent in times total area. So this is what your area inside is going to be. We call that AI for area inside. So that was 40%. You multiply 0.40 times your 5, 0.0625, and that gives you the area inside. So in this shape, we have 2 1/4 square inches inside, based on 40% of the points. Now, if you have 3, then you'd have 30%, 0.30. If you have 0.50, then 50%, you multiply, and you get a slightly higher value. How could we get a better answer, a more accurate answer? What would you do different? what do you think would give you a better answer? Rounding off typically gives us less accuracy. Instead of only doing 10 points, do how many? 100. So 10 points is okay, but 100 points will give us a better answer typically. Now, will 20 be that much better than 10? No. I ask you to do 50 in the book for the curve you drew, and if you go 100, you may not find that much difference. Usually it goes in powers of 10. 10 works, 100's better, 1,000 gives you the improvement, then 10,000, and so on. Okay, so I'll walk off camera here. That was what we did in that problem. Now there are two more problems that I want to look at because they involve this whole idea of a proportion. Now we're going to go to the far left with the camera, and I'll get to there in a few moments, but that's where we'll be next, Marcella. I want to look at page 145. This turns out to be a pretty difficult problem, page 145. So let's look at the problem. It's problem 4. A simple closed curve is drawn on a graph. Now you're told that this grid, I'll slide over now, 36 square inches. Now everything's there that I need. 36 square inches for the grid. And I'm telling you that the area inside the simple closed curve was 9 square inches. And 100 points were selected. So here's the question. How many points should be inside the simple closed curve? That's the question. Okay? Now, to talk about that as we come back to me, we're going to set up what we talked about yesterday as ratios and proportions. Now, a ratio is a fraction. A proportion is what? When I talk about a proportion, what am I referencing? We talked about it yesterday. What is a proportion?
The size of something.
Well, proportions, we can talk about sizes, yes. It is the equality of two fractions. If I set two fractions equal to each other, I have a proportion. So I'm going to go to what we did yesterday on the sideboard. So, Marcella, do you want to bring that in now, please? And tweak it over a little bit to this part first. A little bit more. Okay, this was what we talked about as two ratios done in early Greek mathematics. This was from yesterday. And we say if you have A is to B, A over B, and you have C is to D, C over D, if this is true, so if you have this proportion, then this follows. Now we said this was like cross multiplying, correct? So the argument was that I can take A times D equals B times C. Now I'm going to take the same idea because this is what this unit's about. I have two proportions here. So let's slide over a little bit more now, Marcella, to about right here for the moment. Slide over. There. Area inside the total area, we are arguing, must equal point inside to total points. So let's come back to the document cam for a moment. I'm told that I have 36 for my total area, and I have 9 for inside. And by the way, Marcel, I want you now with camera 2 to come over to here, picking that up. And I have a total of 100 points. So if I take that idea and come over now to this same notion, I have it written as area inside the total area. That's my ratio. Points into total points. That is my other ratio. Those two fractions are equal. We call it a proportion. Now look what I did. I substituted. I had, according to problem 4, that the inside of my curve, this simple closed curve, was 9 square inches. The total area was 36 square inches. And I have 100 points total. What am I supposed to find? Points inside. Now what I am arguing is this is a problem you did earlier. So let me just erase that part for a moment. Originally, I gave you something like 1/4 is equal to something over 100. That was a problem we did in our computational review. And so what we did, if you didn't have this written in already, and I'll just eliminate this part of it for a moment, if you just had this problem written, 1/4 equals something over 100, and I ask you to fill in this missing part, you would divide 4 into 100, and you get your 25 I had written here. The basic principle of fractions tells you do the same to the top. So 25 times 1 is 25, and I have the answer to the problem. Now, is there another way of doing that? This was doing the computational review. We did the first half of the semester. Now, what I'm going to do is slide a little bit so we just to the edge here. So we'll just slide over. There we go. Now, back up just a little bit. Let's see, I don't want to pick up that yet. So back up. There we go. Now let's look at this. I'm saying A times D is B times C. So let's eliminate this for a moment and see what we get. So I'm just going to eliminate this and substitute, and we'll see what we get for our points inside. Now, A was going to be 9 square inches. So I have 9 square inches. And D was my 100. The B was my 36 square inches. And my C was point inside. Okay. Now, I have this. I want just points inside. So what can I do? Divide both sides by 36. Now what happens? This cancels. Okay, this is square inches if you want to look at the units I'm doing here, and square inches here. So on the right side I have left PI, points inside. And what do I get then when I do the fractions here? 9 cancels with the 36, giving me a 4. What can I do with the 4 then? Divide into the 100. So cancel here. And what do I get? 25 for my answer for the points inside. And that is exactly what I got here, doing it this way. So 2 different approaches. Okay, you can zoom out just a little bit and let me walk off camera. And there you can see both parts. Slide over just a little bit to your left. So we can get the, there we go. 2 approaches, correct? Both are valid. Is there any question there as far as process is concerned? You okay? If so, let's come back to question 3. This is on page 145. So question 3 now. Let's go back to the document camera. And we're going to try the same idea. Remember, we're working with proportions. The area of a graph this time, 35 square inches. Okay, so that's the grid, 35 this time. And what are you told as you look at problem 3? You're told that 25 points are what? They're going to be selected. So you're going to plot 25 points, not 10 or not 100, just 25. Of those that you plot, 15 are what? Inside. So my question, without looking at the side board, what's the area inside? So I'll leave that on the screen for a moment.
I thought squiggles were the ones that cross.
Squiggles are simple closed curves. So a squiggle is a simple closed curve. Doodles oftentimes cross, but squiggles are simple closed curves. So again, we'll leave that on the screen. Without referencing the side board, I want you to find the area inside. You have two ways of doing it. And we'll look at both ways in a minute. But I want you to try it without referencing the solution. So again, 35 square inches for the grid. 25 points are plotted. 15 are inside. Step 1, Step 2, Step 3. We have a 3-step process. So keep in mind, 15, 25, 35, counting by 10, starting at 15. Okay, come off there for a moment, Marcella, and back to me. I'm going to point out the 3-step process that we're using. And this is what you have to do each time. It's summarized for you on problem 7, page 139. So let's go back to page 139 for a moment. You first have to have the area of the graph, the grid. Secondly, the percent of points inside, and then you're going to find the area inside. Those are your 3 steps. Now, coming off there for a moment, on page 138, the steps are given in a better way. Page 138. Find the area of the graph. Now, I've told you in this problem, the area of the graph is 35 square inches. I'm going to slide down. The fraction of the points inside. Well, it's the number of points inside over the total number. Now, instead of 34, we have what? 15. Instead of 50, we had 25. So you have 15 over 25. Once you get that, you're supposed to do what? Multiply the percent of points inside times the area of the grid. Those are your 3 steps. Let's leave those there for a moment. So if I look at it just from that 3-step process, I just want it to the edge here. Okay, if I look at this 3-step process, that's what I'm going to go to on the board here. 3-step process. The area inside then becomes the percent of points in times the total area, and here are the numbers given to you in the problem. 15 in, 25 total, 35 square inches. 15 over 25 is 60%. I change that to 0.60, multiply by 35, and I get 21 square inches. I'll just leave that on the board for a moment. Now that's one approach. But this means that you have to memorize this formula, which is not a bad thing. But there is a little better way that we're going to illustrate as we move the camera over. So let's come over here just to the edge there. Now notice this time I'm back to my proportion. Area inside to total area, points inside to total points. We're saying that proportion will allow you to solve this problem. I wanted the area inside. 15 points inside, 25 points total, total area 35. What do we do once we get a proportion? We cross multiply. So I'm saying that 25 times AI, that's where this comes, 25 AI, and then I'm multiplying 35 times 15. That's what I had here. I wanted AI by itself. So I divided both sides by 25. You can see my canceling. I canceled 5 and 5 again and get 21 square inches. Now I'm going to come off camera and leave that there. Okay, so again, that was the idea. Now the question, what method works best? Your choice. Let's go back to the side one more time. Those are both methods right there. You can see them side by side. Notice in order to do problem 4, we just about had to do the one on the left side as you're looking at the screen. More typically, the one on the right side works if you're just hunting for areas inside and you know the percent of points. Okay, so coming off there. What you need to be able to do is, basically replicate what I did, but the curve you drew on the page where the grid was. So if I come back to that page now, and that is on page 131 where you had your grid. This is the graph for the simple closed curve, what I've called a squiggle. The original title of this unit was going to be simply the squiggle, and then I decided to use the more formal name in mathematics, simple closed curve. Now I've asked you not to do 10 points, not to do 20 points. I've asked you to do how many? 50 points. Then you get your answer. Then you go back and do another 50 more points and see if your answer gets different when you do 100. Which one would be typically the better answer? The one with 100 points. Okay? So I would want 100 in the second part. So the place where you keep track of that is on page 137. So here is on 137, problem 6, where you had 50 points selected from the random digit table. And you had the number inside and the number outside. But keep in mind that the percent you want, as we come off that, is going to be the number inside over 50. That's how you're going to get your percent inside. So you go through this whole process and you find the answer using the 3-step process. That's what's done in problem 7. So here's where you actually put your numbers in. And then, as we come off there, problem 8 says, okay, you did 50 points. Let's have you do all 100 as we come to problem 8. And you go through the same 3 steps to find your answer. Now the argument we'll make is that with 100 points you have a better answer. And this all depends on using random digits, a random digit table. Yes?
When the numbers repeat,
So the question is, if you have a pair that repeats, so let's say you get 9, 3, and 9, 3 again.
Yeah.
You count it each time. It would be like if we're thinking of throwing the darts at this curve. One dart lands right in the middle of another. Thinking back to the tales of Robin Hood, where you have one arrow going into the center and then the other arrow splits the arrow that's there. That's called 2 points inside. Okay? Now, that is what I want you to have done for tomorrow, plus all the other problems in the unit. So the goal for tomorrow would be that all the problems are done in the unit so that we could go ahead and do this problem, which I will put on the screen here in just a moment. This problem I'm going to hand out tomorrow, so remind you again, this is a case where we had this shape, and what we're going to do is find the area inside this simple closed curve. And we will try it with maybe 10 points or 20 points and see how good an answer we get. Okay? So then on Thursday, we have a test on this unit. Okay, so the test on this unit is going to involve 10 problems, would be my guess. Some of them like what we've talked about in class today, like number 3, number 4, number 5. I'm also going to expect you to be able to graph points, give me the ordered pairs for points you see, and giving ordered pairs, graph the points. That's just like what's done in problems 1 and 2 on the test at the end of the unit. Now the supplementary problem in this particular unit, and I'll turn to that so you can see what's there, and I'll give you what we will do for this. The supplementary problem is just yet another grid in which I basically ask you to do this, where you draw a simple closed curve on the following page. And the technique we're using here, and I've given it a formal title at this point, the Monte Carlo method to find the area inside the curve. And of course, we then do the steps. Well, rather than have you do that for the supplementary, as we come off there, this is going to become your supplementary. And so this will be for extra credit added on to your test grade, as the supplementary often is. There's our shape, and we'll want you to find the area of that, and I will make a choice in how many points we use tomorrow to do that problem. But that's what we'll do, and that will be due Thursday morning when you come in for the test. The question, where would you use this idea, this Monte Carlo method? And let me give you an example. Are you familiar with some of the problems we have in the lakes, not just in California, but in the United States, where people have brought in fish that shouldn't be there? Okay, what has been the problem in Northern California? It's the northern pike has been introduced into one of the lakes up north. And that fish is doing what to the trout population? Eating it. And we value the trout more than we do the northern pike, although it's argued for people who fish that the northern pike is a rather sporting fish. But if you're wanting trout, you would rather not have the pike in the lake. Yes, you can eat pike, you can fish pike. But in California, the trout, rainbow trout, golden trout, rules. So at this point, how could you estimate the number of northern pike in a lake? How does Fish and Game, or a biologist, usually it's a state biologist, how do they go out and estimate the number of northern pike in the lake? They grid the lake, basically, so they create a big square. Then they want to know the pike in that square, right? So how do they get the fish count? You know what they do? They go out in a boat. They put 2 probes in the water. And then they apply an electric current to the probes. It momentarily stuns the fish, and they all float to the top. So you have this grid marked off. And you count the number of northern pike to the total number of fish floating. So if you had 10 fish floating and 4 are northern pike, 40% of your fish in that grid are pike. Then you know the total area of the lake, multiply your percent times the total area of the lake, and you have what? The number of pike in the lake. Same problem. Okay? And on the basis of that, they can get some sense of how bad the situation is. Now, if you have 80% of your fish trout and 20% pike, what do you expect eventually to happen? More pike, less trout. And that's happened, as I say, in our California waters. What is the fish in the Midwest, Missouri? What fish has been introduced there that's of a similar problem? And this was in the Wall Street Journal just a few weeks back. It's a carp. It's an Asian carp that when you have a boat with a motor out on the lake, the carp gets excited and they fly. They fly out of the water, and a 20-pound carp can hit the boat or the person operating the boat. And if you're going fast enough and a 20-pound carp hits you, you go over with the carp, and the boat keeps going. Okay, so one of the concerns, and why were the carp introduced? Are you aware? They eat what? What you would consider vegetation in a lake. In particular, what is the problem in lakes? You haven't been out on lakes where you have a lot of moss?
I remember all the frog sacks and stuff.
Okay, but basically, this green growth takes oxygen from the water and the fish die. So you bring in Asian carp. They eat the moss and other green vegetation in the lake, keep it healthy. Every fish does well. The Asian carp have done too well. They then do what? Out-eat the fish that you're trying to protect. And so what they're now, by the way, the result of this for the Wall Street Journal is to get people to understand that the Asian carp is a very good fish to eat, and so they're harvesting them and trying to sell them as fish and create a new market. Otherwise, you have too many fish in a lake. Again, all these done with the Monte Carlo method. So it's a very nice technique. Now, if you have gardens, yards, that have irregular shaped dimensions, you use curved boards to create your patio, you have a curved surface for your pool, you can find surface area using this same technique. So this is all about application. You know what you need to have done tomorrow. I want all of the book done at that point. We're going to answer questions tomorrow, and then we'll go ahead and on Thursday have the test. So with that, have a great morning as we go back to Simon and Garfunkel with the boxer. And there was a roll sheet, I think, at some point or not. I'll have to get that out. At the moment, let's go back to the slide and music.